Okay, in these notes we're going to talk about Gay-Lussac's law and the combined gas law. So Gay-Lussac's law establishes the relationship between pressure and temperature, and in this one temperature has to be in Kelvin. Okay, just like when we did Charles's law. So again, what I just said, make sure to convert to Kelvin for temperature. And what this law says is that at a constant volume and mass, the pressure is directly proportional to temperature, so they both increase and decrease together. So here's our equation. Looks a lot like when we did Charles's law. And I know on your sheet there's a triangle that kind of shows the formula stuff. If that doesn't make sense, come talk to me and I'll help you understand how that triangle works on your cheat sheet. Okay, but this one says pressure of 1 over temperature of 1 is equal to pressure of 2 over temperature 2. And if we were going to draw this one, because they're directly proportional, this is going to be a straight diagonal line. Okay, so if we were going to draw this in our notes like you will, you are just going to draw, whoops, kind of curved there, but we want just a nice straight line. Okay, so let's try using those equations. Okay, so it says a container is initially at 0.5 atmospheres and 25 degrees Celsius. What will the pressure be at 125 degrees Celsius? If you remember from the beginning of our notes, we need temperatures in Kelvin. So we need to convert by adding 273 to each of them. Okay, adding 273. So our temperature 1 is 298 Kelvin. Our temperature 2 is 398 Kelvin. Then all we did was we cross multiplied. So we took this times this equals this times this. Okay, and then we just isolated our variable because we're solving for P2. Plug our numbers in and we get 0.67 atmospheres. Okay, then we have the combined gas law. This relates pressure, volume, and temperature, and again, temperature in Kelvin. So pressure and volume are inversely proportional to each other, but directly proportional to T, or temperature. Oops. And so this is the equation. So you're going to see a lot of, it's kind of like, it's combining. That's why it's called the combined gas law. So we can see pressure and volume and temperature. You can see a couple equations combined into one. All right, so here's our equation. It says, notice if you ignore one variable that you have the other laws. So if we ignore the P, we have Charles's law. If we ignore the T, we have Boyle's law. And if we ignore the V, we have Gay-Lussac's law. So we just combined all three into one equation. Okay, if we know all three of them. Okay, therefore this is the equation. And this is kind of what you see in your triangle. Your triangle showing you all the equations combined together to make that combined gas law. So when we go across in the triangle, we're multiplying. When we're doing top to bottom, we're dividing, just like you see here. Okay, so the example they give in your notes is a balloon has an internal pressure of 1 atmosphere and a volume of 5 liters and a temperature of 293 Kelvin. What will the volume be when the balloon rises to an altitude where the pressure is 0.5 atmospheres and the temperature is 258 Kelvin? One thing I'm going to look at is make sure I have things in the same units. So I have atmospheres here. This one's atmospheres. I've got Kelvin here. And I have Kelvin here. And then this one's in liters. And so I know that my answer for volume for the volume 2 is going to also be in liters. Okay. So I take my equation, I isolate my variable, I plug my numbers in, and I get 8.81 liters. Okay, and that's it for the notes. These ones were a little bit quicker. Try a few of these equations, check your answers on Schoology. If this isn't making sense or you need more help, please come with questions when you come back or talk to me and we can go through some together. Thanks.